So we have some more examples here of solving our systems of equations. 3 variables, 3 equations. So row 1, row 2, row 3. And we're still trying to get ourselves into triangular form. So you might want to think about what would be the best first step. Remember, and I'll put these in blue here, that we want to rid ourselves of this x, and then this 3y, and then this negative x. And if we can do that, then we are going to be in good shape. There are also many ways to do this. So don't forget, I will do it one way, but it's not to say that it's the only way. You can follow different steps and still get yourself the same solution, as long as you follow our rules for Gaussian elimination. So what I will do is I will take, and one thing that's kind of nice is with Gaussian elimination is starting your first equation, instead of having a constant in front of the x, like we have 2x in row 1, would be to have not that. So just having an x there would be ideal. So just partly because I haven't done this yet, I'm gonna just exchange row 1 and row 3. That's it. So now, and this is a valid thing to do, I'm just moving my row 3 up. So it is here. My row 2 stays the same. I am not going to touch that. Exactly the same. And then my row 1 will now be at the bottom. So again, it's a valid thing to do. And it does mean that our triangular form will have just an x up at the top when we're done. Now, something I can do here, so that's the first thing I did, is that. Now, the second thing I'm going to do, what is it? Let's see. So if I want to get rid of the x, now I have a 2x. So what I'm going to do now, I'm going to rid myself of this 2x right here, and a couple different ways to do that. But what I will do is I will take 2 times row 2. Okay, so 2 times row 2, and then I'll add to that row 3. So quickly, my row 1 has not changed. So let me keep my row 1 here. Okay. My row 2 is actually going to stay the same as well. And I'm just changing my row 3 here using Gaussian elimination. So I multiply 2 by row 2, and then I'm going to add that to row 3. So notice I will have negative 2x plus 2x. So that will be gone. I will not have an x anymore. That's my goal here. So I no longer have this 2x here. I multiply this by 2, that's 4y plus negative 5y. So that will give me negative y. I have 6z plus a negative z, so a plus 5z. And then I have 26 plus a negative 8. So that will give me a positive 18. And if you ever see me checking, that's just because I do need to make sure that, it's so easy to just have one small thing different. Okay, so now that we have that, now we want to, now the easiest thing to do would actually be to get rid of this negative x that we have here. So the next best move, the next best move would be to do that, because then we have row 2 and row 3 only have 2 variables, so then it's easy to eliminate the y in row 3. So that will be my next move. So let me see my spacing here. Okay, let's see. Okay, so maybe I'll try to fit one more over here. So my third step is fairly straightforward. If I just take row 1 and I add row 2, notice that the x will be eliminated from row 2. So my row 1 will stay the same. So I'm adding row 1 and row 2. You can see them pretty straightforward here. So I'll have a 5y and I'll have a 2z and I will have an 18. Okay, and I don't really need the plus there, but technically it is positive. Then I have negative y plus 5z equals 18. Okay, so now we have these two equations for row 2, row 3, and to get ourselves to triangular form, we want to rid ourselves of that negative y. So there's really only one way to do this at this point, because we need to use row 2 and row 3. We don't want to use row 1 because I could add a variable back. That would be bad. We don't want to add any more variables back in, and so that makes it important that we get eliminate that negative y. So notice the only way to do that is if we take row 2 and add it to 5 times row 3. So if I multiply 5 times row 3, I'll have a negative 5y, and then I add it to row 2 where I have a 5y, and then that y will be gone. So I'm writing back up my row 1 here. That is what I gotta do. And then I have 5y plus 2z equals 18. Then now we're doing this. So row 2 plus 5 times row 3. So 5 times row 3, negative 5y plus 5y, that's gone. 5 times row 3, that's going to give me 25z plus 2z, so 27z. Ooh, all right, so 27z. Then I have 5 times 18. Okay, I think I know what that is. I think it's 90, but let me just double check. 5 times 18, yes, plus 18 from row 2, and we have 108. So, woo, all right. But yay, we now have triangular form, and now we can back substitute to get our solution. So number 5 here, I'll say in order to solve for z, I have 27z, I have 108. All right, so we have z equals a 4. There we are. And then now we just go back. So you're welcome to pause if you want, resubstitute in, make sure you can get those other values. 5y plus 2 times 4 equals 18. 5y equals, so that's 8 minus, that's 10. Y equals 2. And then I'll come down here and do the last step in order to get to solve for x. So in order to solve for x, we can use that first line that we have there, x plus 3y, y being 2, minus z being 4, 5. So it looks like we have this, and it looks like we have this. Woo, okay. So we do need to make sure x, y, z. So don't forget that. It's not like, oh, I just put them in as I find them. No, it is x, y, and z. X being 3, y being 2, z being 4. And that is a lot of steps, but it does give us our solution. So we have another example here. This is 3 equations, but only 2 of them have 3 variables. One of them already only has 2 variables, so let's see what happens there, but that does help us. It means that our focus here is just on eliminating this x and this minus y. So that's what we want to do. But really, the best thing to do would be to switch our row 1 with row 3. And that's just going to give us an x at the top instead of a 2x that we have. In the end, the answer is the same whether you switch it or not. But true Gaussian does have, the x in the front of the first equation. Oops. Okay, 2x. Ooh, these take a while. Okay, so 2x plus 3y plus z equals 5. Now, I think it'd be a good idea at this point, if you are willing, to try to solve this yourself, get some practice with it, and then come back and see if you got the answer right. So if you're feeling even slightly confident here with this, please go ahead and do that. Give yourself that practice, that extra brain boost by working it out yourself. So in order to rid ourselves now of this 2x that we have down here, and then the 3y, the first thing we want to do is eliminate this 2x. And we're going to use row 1, because row 2 doesn't even have an x in it. So in order to do this, I do have to multiply row 1 by a -2. -2 row 1, and then I'll add that to row 3. So my row 1 does not change. There it is. Row 2 does not change. There it is. But row 3, now I have to take every term in my row 1, multiply it by -2, and then add it to row 3. So I'll have -2x plus 2x. That's gone. I will have 2y plus 3y. That will give us a 5y. I will have 4z plus z. That's a 5z. And I will have, let's see, -10 plus 5 is -5. Okay. Now you might look at this and be like, all right, well, that's interesting. Yes, it is. So this will just give us another reminder of things that you can do. So if you felt like it, one thing that you could do is you could take row 3 and just multiply it by 1/5. It is completely valid, as we've seen, to take a row and multiply it by a non-zero constant. So you can just do that simple step in order to help yourself. Notice that when we do that, we will have dividing, so multiplying by 1/5 means dividing each piece by 5. We'll have y plus z equals -1. So every single term got divided by 5, essentially, multiplied by 1/5. And so it will have an equivalent solution to the other, any solution that it would have had I not done that. And what it does, as you can probably see, is it's going to allow us to eliminate the y that we have right here. That would be our next step to get that triangular form. It's going to allow us to do that easier, because now row 1's going to stay the same. We can use row 2. We need to use row 2. So we take row 2 and we will add to that a -2 row 3, and that will be our new row 3. So x minus y minus 2z equals 5. My row 2 staying the same, 2y minus z equals 7. And then now each term multiplied, so I'm multiplying row 3 by -2, but adding it to row 2. So we will have -2 here plus -2y plus 2y, that will be gone. -2z plus -z is a -3z, and 2 plus 7 is 9. There you go. So now we have triangular form, more or less, here. I mean, the point is, now we have an equation with 3 variables, one with 2, one with 1. So it will be straightforward for us to now solve for z. And that will give us, very easily, we can see we have z equals -3. Our second step, solving for y, we have 2y and then minus z, so plus 3, because minus a -3, equals 7. So then we subtract 3 and divide. And then to solve for x, we have x minus y minus 2z equals 5, or x minus 2 plus 6 equals 5. Let's see, so that'll be 4, and then subtract that, we get 1. So we get the solution 1. 2, negative 3.